Tonight, we shall embark upon a journey that no eyes will ever truly witness, a voyage through the immense, unfolding chapters of the far future to the very end of time itself. We shall trace the path of the cosmos as the great fires of the heavens begin to falter, following the final flickers of light until the very last star yields its heat to the encroaching chill of the void. As the world around you fades into a quiet stillness, we prepare to leave behind the familiar glow of our sun and step into a deep time so profound that the stars we see tonight will seem like a half-remembered dream of the ancient past. We live now in what astronomers call the Stelliferous Era, the age of stars. It is a time when the universe is vibrant, teeming with the energy of billions of galaxies, each a shimmering metropolis of light. But this brilliance is a temporary condition. Within the heart of every star, a finite reservoir of hydrogen is being steadily consumed, converted into helium through the relentless process of nuclear fusion. While the heavens may appear eternal, they are, in truth, a vast collection of ticking clocks, each one counting down toward a moment when the fuel will run dry. To understand the end, we must first look at the slowing pulse of the galaxy, as the raw materials of creation begin to vanish from the interstellar medium. In the current age, the Milky Way produces about one new star every year, a modest rate that has sustained our galaxy for billions of years. But the clouds of gas and dust, the cosmic nurseries where stars are born, are being depleted. Every time a new star ignites, it locks away a portion of the galaxy's hydrogen. While some of this material is returned to the void through supernovas and stellar winds, much of it remains trapped in the cold, dense remnants of dead worlds. Slowly, almost imperceptibly, the birth rate of the universe is falling. The great nebulae that once glowed with the fire of thousands of newborn suns are growing dim, and the vibrant nurseries of our youth are turning into silent deserts of cold, inert gas. As we move forward 100 billion years into the future, the night sky begins to undergo a fundamental transformation. The massive, brilliant blue stars, the titans that burn with a fierce intensity, are the first to vanish. These stars live fast and die young, exhausting their fuel in a mere few million years. In this future sky, the familiar constellations we know today have long since dissolved, replaced by a much dimmer, redder population of aging suns. The universe is losing its blue, vibrant hues, settling into a deep, somber orange. It is the beginning of the great cosmic twilight, a period when the supply of fresh gas becomes so scarce that star formation across the entire cosmos effectively grinds to a halt. Imagine standing on a world in this distant era, looking up at a sky that is far emptier than our own. The expansion of the universe has continued its relentless acceleration, driven by the mysterious influence of dark energy. Galaxies that were once our neighbors have been pushed so far away that their light can no longer reach us. They have slipped over the cosmic horizon, leaving our local group of galaxies isolated in a vast, expanding island of darkness. The Milkomeda galaxy, the result of the long-ago collision between our Milky Way and Andromeda, is all that remains visible. It is a lonely city of light, drifting in an ocean of absolute nothingness, its internal fires cooling with every passing millennium. The cooling of the universe is not a sudden event, but a lingering, graceful decline. We must consider the physics of the red dwarfs, the smallest and most modest of all stars. These diminutive suns are the true survivors of the cosmos. While a massive star might burn through its fuel in the blink of an eye, a red dwarf sips its hydrogen with incredible parsimony. Because they are so small, their internal convection currents are much more efficient, allowing them to circulate their fuel from the surface down to the core. This ensures that almost every atom of hydrogen is utilized. A red dwarf can burn steadily for trillions of years, 1,000 times longer than the current age of the universe. They are the long-lived sentinels that will guard the exit of the Stelliferous Era. In this deep future, the red dwarfs are all that remain. The universe has become a graveyard of white dwarfs, neutron stars, and black holes, punctuated only by these faint ruby-colored sparks. These stars are so dim that they do not provide enough warmth to sustain liquid water on any planets that might orbit them, unless those planets are tucked in incredibly close, locked in a permanent, frozen embrace. The era of complex life, as we understand it, is drawing to a close. The universe is settling into a long, slow hibernation, where the passage of time is no longer measured in the life cycles of civilizations, but in the slow cooling of these final, stubborn embers. We must linger on the silence of this period. When we speak of 1 trillion years, we are speaking of a duration that makes the current age of 13.8 billion years seem like a heartbeat. During this immense span, the red dwarfs will slowly change their composition. As they finally exhaust their hydrogen, they will not swell into red giants as our sun will. Instead, they will grow hotter and bluer for a brief period, becoming blue dwarfs before they finally run out of fuel entirely. This is the final act of the stellar drama. One by one, these last outposts of light will flicker and fade, turning into white dwarfs, cold, dense spheres of degenerate matter that no longer produce any energy of their own. The transition from a universe filled with light to a universe filled with shadows is the most significant threshold in cosmic history. It marks the end of the age of activity and the beginning of the age of remnants. In the minds of the astronomers, this is the point where the entropy of the universe reaches a critical state. The energy that was once concentrated in the hearts of stars is now spread thin, scattered across a void that is expanding faster and faster. The darkness is not just an absence of light. It is a physical reality that is taking over the cosmos. Every star that dies is a door, closing on the possibility of warmth and life, leaving the universe a little colder, a little darker, and a little more silent. Consider the physical fate of the white dwarfs that were once stars. They are composed of carbon and oxygen, packed so tightly that a teaspoon of their material would weigh as much as an elephant. They have no internal fire to keep them warm. They simply radiate away the heat they accumulated during their long lives. They will spend the next quadrillion years cooling, slowly turning from white to yellow, then orange, and finally a dull, deep red. They are the glowing coals of a finished fire, the fading memories of a time when the universe was young and full of potential. When they finally cool to the temperature of the background space, they will become black dwarfs, invisible, frozen hulks drifting in the eternal night. But even in this encroaching darkness, the universe is not entirely still. There is a rare and haunting phenomenon known as a flare from a dying red dwarf, or the occasional collision of two brown dwarfs, objects that were never quite massive enough to become stars. When two of these failed stars collide, they can briefly merge to create a new, low-mass star, a born-again sun that flickers into existence for a few billion years before it, too, fades away. These are the final, desperate gasps of the Stelliferous Era, tiny sparks in a darkness that is now billions of light years across. They are the exceptions that prove the rule. The age of light is over. As you lie here, reflecting on the fading of the cosmic lights, try to grasp the scale of the isolation. In this future, the light from the Big Bang has been stretched so thin by expansion that it is no longer detectable. The evidence of our origins has been erased. If a consciousness were to emerge in this era, it would see a sky with only one galaxy, and no sign that the universe was ever any different. They would live in a world of absolute, permanent night, with no stars to guide them and no history to look back upon. We are the lucky ones, living in the morning of the universe, when the sky is still full of story and light. The death of the last star is the ultimate deadline of the cosmos. It represents the moment when the universe loses its ability to fight against the absolute zero of space. Every photon that was ever emitted by every star that ever lived is still out there, traveling through the void, but they are being stretched and diluted until they are no more than a whisper. The universe is becoming a place of equilibrium, a place where there are no more gradients of temperature, no more flows of energy, and no more possibilities for change. The fading of the lights is the slow, majestic descent into the long sleep of the cosmos. We shall continue to trace this journey, moving deeper into the shadows where only the black holes and the frozen remnants remain. We will see how gravity continues to shape the dark, and how the very atoms themselves may eventually succumb to the passage of time. But for now, let the realization settle within you. The light we see tonight is a precious and fleeting gift. We are the inhabitants of the bright years, the witnesses to the universe's most vibrant chapter. The end of the stars is the beginning of a silence that will last for a number of years so large it defies any name. The final star to die will likely be a small, lonely red dwarf in the furthest reaches of a decaying galaxy. Its light will flicker, its internal convection will fail, and its core will finally grow still. In that moment, the universe will pass through a doorway from which there is no return. The last sun will have set, and the era of the Dark Sentinels will truly begin. The story of light will be finished, and the long, slow evaporation of the remnants will become the only narrative left in the deep, expanding dark. As we move into the second chapter of the deep future, we find ourselves in an era defined by the most patient and humble of all celestial bodies. This is the age of the Red Sentinels, the M-dwarf stars. While the more brilliant stars of our youth have long since collapsed into dark remnants, these small, ruby-colored suns remain, burning with a slow and steady constancy that defies the encroaching chill. They are the ultimate survivors, a generation of stars that were born in the galaxy's prime, but whose destiny is to watch over its long, slow decline. In this period, which begins roughly 100 billion years from now and stretches for tens of trillions of years, the universe is no longer a place of chaotic, blue-white fire, but a realm of permanent, dim twilight. To understand why these stars endure while others fail, we must look into their internal architecture. A red dwarf is a master of economy. Unlike our sun, which is structured in distinct layers that prevent its hydrogen fuel from fully reaching the core, a red dwarf is entirely convective. Imagine the star as a vast, churning cauldron where the hot plasma from the surface is constantly pulled down into the nuclear furnace, while the products of fusion are pushed back out. This ensures that every single atom of hydrogen available to the star is eventually consumed. They do not leave behind unused fuel. They burn until the very last drop is gone. Because of this efficiency, and because their fusion rates are so incredibly low, they can endure for up to 10 trillion years. They are the marathon runners of the cosmos, moving with a pace that makes the history of the Earth seem like a mere instant. In this era, the night sky as we know it is a myth. The Milky Way has merged with its neighbors, forming a single, bloated, elliptical galaxy. Dark energy has pushed every other galaxy beyond the reach of our sight, leaving our local system alone in a dark, expanding bubble. Within this massive, aging galaxy, there are no more blue stars to illuminate the dust clouds. The nebulae have gone dark. The only light comes from the trillions of red dwarfs scattered like dying embers across a vast field of black. If you were to stand on a planet during this time, the sun in your sky would be a deep, angry red, casting long, stark shadows across a landscape of frozen ices. The day would never truly be bright, and the night would be a profound, absolute blackness, devoid of the familiar dusting of distant star cities. We must consider the possibilities for life in this twilight age. Astronomers have long debated the habitability of planets orbiting red dwarfs. Because these stars are so cool, a planet must orbit very close to stay warm enough for liquid water. So close that it likely becomes tidally locked, with one face eternally baked in red light, and the other frozen in a permanent, starless night. Yet, in the thin band of twilight between these extremes, a sliver of habitability might persist. In the era of the Red Sentinels, these planets are the only remaining oases in a desert of cold. Any civilization that exists in this time would view the red dwarf as a god of infinite patience, a source of energy that has lasted for more generations than they can possibly count. But even the patience of a red dwarf has its limits. As the trillions of years pass, the composition of these stars begins to shift. As they consume their hydrogen, the concentration of helium in their cores increases, causing the star to grow slightly smaller and hotter. Toward the end of their lives, they may transition into what scientists call blue dwarfs. This is a purely theoretical state, as the universe is not yet old enough for any red dwarf to have reached this stage. They will brighten, their light shifting from red to blue as they use up the final remnants of their fuel. It is a final, brief surge of vitality, a last defiant stand against the cooling void, before the fires of fusion finally, inevitably, go out. The scale of time in this era is what truly challenges our comprehension. We are currently 13.8 billion years old. The era of the Red Sentinels lasts for over 10,000 billion years. If the entire history of the universe up to this point were represented by a single day, the age of these red stars would last for thousands of years. In this immense span, the very structures of the galaxy begin to change. Stars occasionally pass close to one another, their gravity flinging planets out into the interstellar dark, or dragging them into the fires of the star itself. The clockwork of the galaxy is slowly winding down, losing its energy to the expansion of space and the chaotic interactions of its members. There is a strange and beautiful intellectual honesty in observing this decline. We are watching the second law of thermodynamics play out on a galactic scale. Entropy, the measure of disorder, is rising. The concentrated energy that was once present in the hot, dense Big Bang is being spread thinner and thinner. The red dwarfs are the last bastions of concentrated energy. They represent the final opportunity for complex chemistry and biological life. Every red dwarf that enters its final blue dwarf phase is a beacon announcing the end of the Stelliferous Era. Once they fade, there will be no more light in the universe that is not a product of decay or the slow evaporation of mass. As you lie here, contemplate the silence of a red dwarf planet. There is no wind, for there is no sun-driven weather on a global scale. There is no sound of rain, for the atmosphere is thin and frozen. There is only the steady, unblinking red eye of the star in the sky, a sentinel that has watched the universe grow old. The sense of peace in this era is absolute, but it is the peace of a tomb. The galaxy is no longer a place of birth and growth, but a place of maintenance and survival. The red dwarfs are not just stars. They are the final witnesses to the story of light, the last guardians of the cosmic fire. In these final trillions of years, the red dwarfs will eventually undergo their own transformation. Without enough mass to explode as supernovas, they will quietly collapse into white dwarfs, spheres of helium and carbon about the size of the Earth, but with the mass of a star. These remnants will be hot at first, glowing with the residual energy of their former lives, but they will produce no new energy of their own. They are the skeletons of the Red Sentinels, the final physical remains of the age of stars. When the last red dwarf fades into a white dwarf, the universe will experience its final sunset. The Stelliferous Era will be over, and the lights of the universe will have gone out forever. We must imagine the moment when the very last red dwarf in the entire cosmos begins to fail. It would be a star that was born long after our own sun was forgotten, perhaps formed from the accidental collision of two brown dwarfs in the deep dark. For trillions of years, it has been the only light for billions of light years in every direction. As its core fusion finally sputters and dies, its light will redden and dim, flickering like a candle in a vast, cold cathedral. When it finally vanishes, the era of the Red Sentinels will end, and the universe will enter a state of darkness that is not merely the absence of light, but the absence of the possibility of light. The transition to the next era, the degenerate era, is a transition into a world of ghosts. The galaxy will be populated by white dwarfs, neutron stars, and black holes, all drifting in the dark. There will be no more sunrises, no more seasons, and no more life as we know it. The story of the universe will shift from the narrative of fire to the narrative of gravity and decay. The Red Sentinels were the last bridge to the world we know. Their disappearance marks the end of the universe's childhood and its entry into a long, eternal adulthood of shadows. Linger for a moment on the weight of that final flicker. For 10 trillion years, that star provided a center to a small pocket of the void. Now, there is no center. The expansion of space will continue to pull the remnants further and further apart, until even the white dwarfs of our own galaxy are separated by distances that light cannot bridge. The universe is becoming a place of absolute isolation, a collection of lonely remnants in an infinite night. The Red Sentinels did their duty. They held back the dark for as long as the laws of physics would allow. As the world around you remains in a quiet stillness, let the image of the last red dwarf comfort you. It represents the incredible endurance of matter and the persistence of light. We are lucky to live in a time when the sky is crowded and bright, but we must respect the slow, steady rhythm of the red stars that will follow us. They are the true masters of time, and their long, dim lives are the foundation upon which the final chapters of the universe will be written. We are the flash, but they are the glow that remains. Rate 100%, pitch 1%. The era of the Red Sentinels is the last great epoch of light. When it concludes, the very nature of existence will change. The universe will no longer be defined by what it is creating, but by what it is losing, as we prepare to move into the third chapter, the Great Galactic Graveyard. We must say goodbye to the suns and prepare to walk among the ruins. The light is fading, the sentinels are falling, and the long, cold reign of the dark remnants is about to begin. We have stepped across the threshold into an age of absolute shadows. The Stelliferous Era, that brief and brilliant morning of the cosmos, has finally reached its conclusion. The last red dwarf has flickered out, and the universe has entered the degenerate era, a time that will last for a duration so immense that the age of stars will eventually appear as nothing more than a microscopic, bright speck in the distant past. We find ourselves now in the Great Galactic Graveyard, a realm where the lights have been extinguished, but the heavy, silent remnants of the former age remain, drifting through the dark like the monuments of a forgotten civilization. This is a universe populated not by fire and light, but by white dwarfs, neutron stars, and the ever-watchful presence of black holes, all bound together by a gravity that no longer has anything to illuminate. As you lie here, imagine the silence of this future Milky Way. It is no longer a spiral of glowing gas and vibrant suns, but a vast, dark swarm of cold, dense objects. The most common residents of this graveyard are the white dwarfs, the cooling embers of stars like our own sun, and the billions of red dwarfs that followed it. These objects are truly extraordinary in their construction. They are composed of degenerate matter, a state of existence where atoms are packed so tightly together that they are supported not by the heat of fusion, but by the quantum pressure of electrons refusing to occupy the same space. A white dwarf holds the mass of a sun within a volume no larger than the Earth, creating a surface gravity so intense that it would crush any familiar structure into a layer of atoms only 1 centimeter thick. These white dwarfs are the ultimate witnesses to the history of the galaxy. When they first formed, they were white-hot, glowing with the residual energy of their former lives. But in the great Galactic Graveyard, they have begun the longest cooling process in nature. Over quintillions of years, they slowly bleed away their heat into the vacuum of space, fading from white to yellow, then to a dull, deep orange, and finally to a lightless, frozen state known as a black dwarf. A black dwarf is a world of solid diamond and crystallized oxygen, a frozen jewel of immense mass drifting in total darkness. Because the universe is currently so young, not a single black dwarf yet exists. They are a treasure that only the deep future will ever possess. Beyond the white dwarfs, we find the neutron stars, the crushed hearts of the massive titans that died in supernovas billions of years before. A neutron star is even more extreme than a white dwarf, packing the mass of 1.5 suns into a sphere only 20 kilometers wide. These objects are made of pure neutrons, a material so dense that a single teaspoon of it would weigh as much as a mountain range. In the early days of the graveyard, some of these stars still spin with incredible speed, their magnetic fields beaming radio waves into the dark like lonely lighthouses. But as the quadrillions of years pass, even these pulsars begin to slow down. Their magnetic energy is spent, their rotation falters, and they too become silent. Dark sentinels, invisible to any eye, yet possessing a gravitational pull that can still warp the paths of any objects that stray too close. The graveyard is not a static place. It is governed by a slow, majestic, and often violent dance of orbits. In our own time, the distance between stars is so vast that they rarely collide. But in the immense time scales of the degenerate era, the improbable becomes inevitable. Over trillions and quadrillions of years, the random movements of these dark remnants lead to close encounters. When 2 white dwarfs or 2 neutron stars pass near one another, they engage in a gravitational tug-of-war that can have profound consequences. Sometimes, one object is flung out of the galaxy entirely, cast into the intergalactic void to wander the emptiness forever as a lonely orphan. Other times, the objects are drawn together, their orbits decaying as they release ripples in space-time known as gravitational waves. When these remnants finally collide, they create the only remaining bursts of light in the universe. If 2 white dwarfs merge, they may exceed the limit of their stability and explode in a spectacular Type 1a supernova, a brief and ghostly reminder of the Stelliferous Era. If 2 brown dwarfs, the failed stars that were never quite hot enough to ignite, collide, they may finally gain enough mass to spark nuclear fusion, creating a born-again red dwarf that will flicker for a few trillion years before fading once more. These are the rare, flickering candles in the great graveyard, tiny moments of warmth in a universe that is otherwise approaching absolute zero. They are the exceptions that highlight the rule of the great, all-encompassing dark. We must also consider the fate of the planets that once orbited these stars. If the Earth managed to survive the expansion of the Sun into a red giant, it would now be a frozen, lightless husk orbiting a black dwarf. In the Great Galactic Graveyard, these planets are subjected to the slow, relentless erosion of gravity. Close encounters with passing remnants will eventually strip planets away from their parent stars, sending them drifting into the interstellar dark. These rogue planets are the forgotten children of the graveyard, frozen worlds of iron and rock that will never again know the warmth of a sun. They are the silent witnesses to the biological history that once thrived in the Age of Light, now preserved in a deep frozen state for the rest of eternity. As the quadrillions of years turn into quintillions, the galaxy itself begins to undergo a process known as evaporation. In the chaotic dance of the dark remnants, some objects inevitably gain enough kinetic energy from their encounters to reach escape velocity. One by one, the white dwarfs, neutron stars, and black holes are ejected from the galactic center. The galaxy, once a cohesive city of light, is slowly dissolving. It is losing its members to the vast, expanding void between the galaxies. Eventually, 90% of the galaxy's mass will be flung into the intergalactic medium, leaving behind only a small, tightly bound core of remnants that will eventually be swallowed by the supermassive black hole at the center of the galaxy. This evaporation is the ultimate expression of the second law of thermodynamics, the order that was once represented by the structure of the Milky Way is being broken down and scattered. The universe is becoming a place of increasing isolation, where the distances between individual objects are so great that light can no longer bridge the gap. In the Great Galactic Graveyard, the concept of a neighbor has vanished. Every white dwarf, every neutron star, and every rogue planet is an island of matter in an ocean of nothingness that is billions of light years wide. The universe is not just dark. It is lonely, a vast expanse of space where the individual pieces of the puzzle have been scattered so far apart that they can never be reunited. Linger for a moment on the absolute cold of this era. In our own time, the cosmic microwave background provides a faint warmth of nearly 3 degrees above absolute zero. But in the deep future of the graveyard, even this relic radiation has been stretched and cooled by the expansion of space until it is virtually non-existent. The temperature of the universe is now indistinguishable from absolute zero. In this profound cold, the very movement of atoms begins to slow. The white dwarfs, once the hottest objects in the galaxy, have become the coldest. They are spheres of solid crystal, their heat long since spent, drifting in a vacuum that offers no resistance and no warmth. The intellectual honesty of this narrative requires us to acknowledge that the Great Galactic Graveyard is not the final end. It is merely a long, slow transition. The remnants that survive this era will face an even more mysterious fate as we move toward the age of proton decay. But for now, we must appreciate the majesty of this graveyard. It is a monument to the endurance of matter. The carbon that was forged in the hearts of the first stars is still here, now locked in the diamond hearts of the black dwarfs. The iron that once carried oxygen through the veins of living beings is still here, now part of the cold crusts of neutron stars. Nothing has been destroyed. It has only been rearranged into a form that is more stable, more silent, and more permanent. As you contemplate this dark future, feel the connection between your own fleeting existence and the eternal remnants of the graveyard. We are the inhabitants of the bright, chaotic morning, a time of change and growth. But the remnants are the keepers of the long afternoon. They represent the ultimate state of matter in a universe that is cooling and expanding. The graveyard is not a place of horror, but a place of rest. It is the final destination for every atom that has ever been part of a star, a planet, or a person. We are all on a journey toward this, silence, a journey that began with the first light and will end in the profound, dark peace of the great galactic graveyard. The scale of time in the graveyard is such that the entire history of the human race could be repeated 1 trillion times, and it would not fill even a fraction of this era. We are looking at a period that spans from 10 to the power of 15 years to 10 to the power of 20 years. In this span, the very shapes of the remnants may begin to change. Some theories suggest that in the absolute cold, quantum tunneling might allow for the slow transformation of elements, where even the lightest atoms eventually turn into iron, the most stable nuclear state. If this is true, the graveyard will eventually be populated by iron stars, cold, dark spheres of pure iron, the final and most stable monuments of the atomic age. Consider the silence of an iron star. It is an object that will never change, never glow, and never die. It is the ultimate expression of the universe's desire for stability. It is a world of perfect, cold order, a final period at the end of the long sentence of cosmic history. As we prepare to move into the next chapter of our journey, we must leave the remnants behind and look toward the only things that still possess a kind of life in the dark, the black holes. They are the masters of the next era, the titans that will outlast even the iron stars. The graveyard is their kingdom, and they are the only ones who will remain to witness the final evaporation of matter itself. The journey through the great galactic graveyard has shown us the ultimate fate of the stars. We have seen the lights fade, the heat vanish, and the matter settle into a state of frozen, crystalline silence. The universe is no longer a place of action, but a place of memory, where every cold remnant carries the legacy of a time when the heavens were full of fire. As the world around you remains in a quiet stillness, let the peace of the graveyard settle into your mind. You are part of a narrative that is larger than light, a narrative that continues long after the stars have gone out. The graveyard is the end of the beginning and the beginning of the eternal night. In the silence of the night, the stars you see above you are already on their way to this destination. They are the white dwarfs and neutron stars of the future, the black dwarfs and iron stars of the deep dark. We are the lucky witnesses to their brilliant youth, but we must also respect their long, silent adulthood. The great galactic graveyard is the final home for all the stardust of the cosmos, a place of absolute rest and infinite time. And as we move forward, we carry with us the knowledge that even in the dark, the laws of physics remain, guiding the remnants through the eternal night with a precision that is as beautiful as it is cold. We have entered a period of time that renders all of previous history a mere statistical flickering. This is the era of the long twilight, a span of quintillions of years where the universe is populated by the cooling, crystallizing remains of what were once glorious suns. The white dwarfs, those dense spheres of carbon and oxygen, have now been radiating their heat into the void for a time longer than the Stelliferous Era by a factor of millions. They are the true survivors of the atomic age, but they are subject to a slow internal transformation that will eventually turn them from glowing embers into the hardest, coldest objects in the cosmos. As you lie here, imagine the internal change within a white dwarf. In our current age, these stars are composed of a fluid-like plasma of nuclei. But as they reach the profound cold of the far future, their internal motion begins to slow. When the temperature drops below a certain threshold, the carbon and oxygen atoms stop flowing and begin to lock into a rigid geometric lattice. This is the process of crystallization. The white dwarf is literally turning into a diamond the size of the Earth, a sphere of pure, shimmering crystal, with a density so high that it warps the space around it, drifting in a darkness so absolute that no light will ever reflect off its facets. These black dwarfs are the final, frozen monuments of the stars, the ultimate expression of order in a universe that has otherwise succumbed to entropy. The scale of time required for a white dwarf to become a black dwarf is staggering. It takes roughly 10 to the power of 15 years, 1 quadrillion years, for a white dwarf to cool to the temperature of the cosmic background. For comparison, our universe is currently only 10 to the power of 10 years old. In this era, the very expansion of space has reached such a pitch that even the galaxies themselves have evaporated, their remnants scattered across a void that is trillions of light years wide. Every black dwarf is now an island of matter separated from its neighbors by distances that can no longer be measured in human terms. They are the lonely residents of a vast, lightless ocean, their diamond hearts beating with a rhythm of quintillions of years. But as we look deeper into the twilight, we encounter a theoretical shadow that threatens even these diamond monuments. This is the mystery of proton decay. While the laws of physics, as we understand them today, suggest that protons, the very building blocks of atoms, are stable, many grand unified theories predict that they have a finite lifespan. If this is true, then matter itself is not eternal. After a duration of approximately 10 to the power of 34 years, the protons within the black dwarfs will begin to disintegrate. One by one, the atoms will fall apart, turning into positrons and photons that dissipate into the void. The diamond hearts will not break. They will simply evaporate, vanishing into the darkness like a mist at sunrise. Consider the slow and agonizing nature of this evaporation. It would begin at the surface and move inward, a gradual thinning of the density that has held firm for aeons. A black dwarf that has stood for a trillion years would slowly lose its mass, its gravity weakening, its crystalline structure dissolving into a spray of subatomic particles. This is the ultimate heat death of the atomic universe. It is the moment when the very substance of our reality, the carbon, the oxygen, the iron, finally yields to the passage of time. The graveyard of the galaxies is being emptied, not by the violence of a collision, but by the slow internal rot of the building blocks of matter itself. Linger for a moment on the silence of this dissolution. There is no sound to this decay, no flash of light, and no sudden release of energy. It is a quiet, steady erasure. The rogue planets, the frozen iron stars, and the diamond black dwarfs are all subject to the same fate. The universe is becoming a place of absolute simplicity once again, a realm populated only by the lightest of particles and the longest of wavelengths. The complexity that was built up over trillions of years is being unraveled, thread by thread, until only the vacuum remains. The long twilight is the period when the universe finally lets go of its physical form. Intellectual honesty requires us to acknowledge that proton decay has never been observed in our laboratories. We have built massive tanks of water deep underground, watched over by sensitive detectors for decades, and we have yet to see a single proton die. If the proton is truly stable, then the black dwarfs and iron stars will endure for a time that is essentially infinite. They would become iron stars, where quantum tunneling slowly converts all matter into the most stable state over a period of 10 to the power of 1,500 years. In such a universe, the graveyard is permanent, a museum of frozen spheres that lasts until the very concept of time loses its meaning. But the current weight of theory leans toward decay, toward a universe that eventually, mercifully, clears its canvas. As the white dwarfs transition into their black dwarf state and begin their long evaporation, the universe reaches a level of cold that is almost impossible to define. We are now far beyond the 3 degrees of the Big Bang's afterglow. The temperature of space is measured in fractions of a trillionth of a degree above absolute zero. In this cold, the only thing that still moves is the slow, rhythmic decay of the atoms. The universe is a vast, dark clock, and every decaying proton is a tick toward the final midnight. The long twilight is the slow, majestic descent into a state where matter and energy are no longer distinct, but are merely ripples in an infinite frozen sea. We must imagine the state of the universe when the very last atom finally falls apart. It would be an atom of iron, perhaps, located in the core of a once massive star. For 100 trillion years, it has held its place, a witness to the entire history of the cosmos. As its final proton decays, it releases a tiny, final burst of energy, a single photon that will travel for an eternity through an empty sky. In that moment, the era of matter is over. The universe is no longer a place of things, but a place of light. Light that has been stretched to such extreme lengths that it can no longer interact with anything. The long twilight of the white dwarfs has concluded, and the reign of the dark remnants begins. As you lie here, reflecting on the end of matter, try to find peace in the scale of the process. We often fear death because it feels sudden and final, but the universe shows us that the end is a process of incredible patience and grace. The stars do not go out in a hurry. The atoms do not dissolve in a panic. Everything is given its time, trillions and quintillions of years to exist, to cool, and to slowly return to the void. We are part of a narrative that values the journey of every single particle. The dissolution of the black dwarfs is the final act of a story that has been told with absolute care and meticulous detail. The transition to the fifth era, the black hole era, is a shift into a world where only the most powerful gravitational wells survive. As the matter of the black dwarfs and iron stars evaporates, the only things that remain are the black holes, which have spent the previous aeons growing fat on the remnants of the galaxies. They are the only structures left that can still be called objects. But even they are subject to the laws of the deep future. The story of the universe is moving from the decay of the small to the evaporation of the large. The twilight has faded, and the true eternal night is about to begin. In the silence of your room, the atoms of your own body are already beginning their long journey toward this fate. The carbon in your bones and the oxygen in your blood are the same atoms that will one day form the diamond heart of a black dwarf. You are carrying a piece of the deep future within you right now. You are part of the material legacy of the stars, a legacy that will endure for a time so vast it is almost infinite. But eventually, you too will return to the void, not as dust, but as light. You are a temporary arrangement of the universe's most precious materials, a brief and beautiful flicker in the long twilight. The scale of time we have discussed is a reminder of our own significance. If the universe has trillions of years to cool and quintillions of years to decay, then the few decades of a human life are a rare and precious opportunity. We are the ones who get to experience the universe while it is still warm, while it is still full of matter, and while the light still shines. We are the witnesses to the bright years. As we move forward into the next chapter, the reign of the dark remnants, we must leave behind the world of atoms and enter the world of pure gravity. Rate 100%, pitch 1%. The black dwarfs are the final monuments of our kind of universe. They are the end of the story of the periodic table, the final transformation of the elements. As they fade from view, the universe becomes a place of absolute transparency. There is nothing left to block the path of a photon, nothing left to cast a shadow. The long twilight has ended, and the dark titans have taken their place as the sole rulers of the expanding dark. The silence is now complete, and the final evaporation of the universe has begun. We have emerged into an epoch where the very definition of a thing has been narrowed to the most extreme limits of physics. The atoms of the old world are gone, dissolved into a spray of subatomic ghosts through the slow, relentless erosion of proton decay. The diamond hearts of the black dwarfs and the iron shells of the frozen stars have vanished, leaving behind a universe that is vast, transparent, and impossibly empty. In this absolute desolation, only one type of structure remains: the black holes. These are the dark remnants, the gravity wells that once sat at the centers of galaxies or formed from the collapse of the most massive stars. They are now the sole monarchs of the cosmos, ruling over a kingdom of nothingness that stretches for a number of light years, that has no meaning in a world without observers. In this black hole era, which begins roughly 10 to the power of 40 years from now, the universe is a place of profound, terrifying simplicity. The supermassive black holes, some weighing as much as 50 billion suns, have long since consumed every scrap of matter within their reach. They sit in the centers of what were once great galactic clusters, now isolated from one another by distances so vast that light from one can never hope to reach the next. These are the heaviest objects to ever exist, yet in the absolute dark, they are invisible. They are not made of matter, but of warped space-time itself, spheres of darkness that have trapped the history of the universe behind their event horizons, locked away forever from the reach of the outside world. As you lie here, imagine the stillness of this era. The expansion of the universe has continued for trillions upon trillions of years, diluting any remaining energy until the background temperature is effectively zero. There is no heat, no light, and no movement, save for the slow, majestic rotation of these dark titans. Yet even in this state of ultimate isolation, the black holes are not truly eternal. According to the insights of Stephen Hawking, a black hole is not a perfect trap. Through a subtle quantum process occurring at the very edge of the event horizon, they possess a temperature. They are, in fact, glowing, not with visible light, but with a faint thermal hiss known as Hawking radiation. This process is the universe's final, most patient mechanism for recycling energy, as the black holes begin to bleed their mass back into the vacuum of space. Hawking radiation is a consequence of the uncertainty principle, where pairs of virtual particles are constantly popping in and out of existence in the vacuum. Normally, these pairs annihilate each other instantly, but at the edge of a black hole, one particle may fall into the abyss, while its partner escapes into the void. To an outside observer, it looks as though the black hole has emitted a particle and lost a tiny fraction of its mass. For a stellar mass black hole, this process is agonizingly slow, taking 10 to the power of 67 years to evaporate. For the supermassive giants, the timeline stretches to 10 to the power of 100 years, 1 Google years. This is the reign of the dark remnants, a Google years of slow, imperceptible shrinking, as the titans of gravity gradually exhale their mass into the dark. Consider the perspective of time during this era. In our Stelliferous Era, we measure time by the movement of planets and the burning of stars. But in the black hole era, time has effectively slowed to a crawl. 1,000,000 years pass, 1,000,000,000, 1,000,000,000,000, and the black hole has changed its mass by less than the weight of a single human hair. The universe is a place of extreme patience. If a consciousness could survive in this time, it would witness a reality where change is something that occurs over scales of time so vast that the entire history of the stars would be forgotten in the first few seconds of its watch. It is the ultimate adulthood of the cosmos, a period of slow, rhythmic breathing that will last for an eternity before the final exhale. As the black holes shrink, they actually grow hotter. This is the great irony of black hole thermodynamics. A massive black hole is incredibly cold, But as it loses mass through radiation, the rate of that radiation increases. In the final stages of its life, a black hole that has survived for a googol years will begin to accelerate its evaporation. What began as a faint, subatomic whisper becomes a roar. In its final moments, the black hole will release as much energy as 1 billion nuclear bombs in a spectacular flash of light and gamma rays. This is the final firework of the universe, the last moment of high energy that will ever occur. One by one, the dark remnants will vanish in these sudden, violent bursts, leaving behind only a spray of photons and gravitons to wander the eternal night. The intellectual honesty of this narrative requires us to admit that we are moving into the realm of the extreme unknown. While Hawking radiation is a widely accepted theoretical prediction, it has never been observed. If black holes do not evaporate, then the universe faces a different kind of eternity, one where these dark spheres drift forever in a vacuum that never changes. But if the laws of quantum mechanics and general relativity hold true, then even the mightiest black holes are destined to vanish. The reign of the dark remnants is a story of the slow victory of the quantum world over the gravitational world. It is the final process of purification, where the last concentrations of mass are broken down and returned to the field of the vacuum. Linger for a moment on the absolute transparency that follows. Once the last supermassive black hole has evaporated, the universe is truly empty. There are no atoms, no stars, no remnants, and no wells of gravity. There is only a thin, cold gas of photons, neutrinos, and electrons, stretched to such extreme wavelengths by the expansion of space that they can never encounter one another. The distance between a single photon and its neighbor is now larger than the entire observable universe of our time. Every particle is in its own private cosmos, a lonely traveler in a dark that will never end. The reign of the remnants is over, and the era of the void has begun. In the silence of your room, reflect on the power of gravity that we have discussed. In our world, gravity is the force that keeps our feet on the ground and the Earth in orbit. It is a creative force, a builder of worlds. But in the deep future, gravity is a hoarder, a collector of the universe's remains. The black holes are the final vaults, the places where the matter of the galaxies was stored before its final destruction. When you feel the weight of your own body as you lie there, you are feeling a small, gentle version of the same force that will one day rule the entire universe. You are part of the gravitational story, a story that ends with the total evaporation of everything we know. The scale of time we are now contemplating, 1 googol years, is the ultimate horizon of human thought. To write the number 1 followed by 100 zeros is easy, but to feel it is impossible. It is a number so large that if you were to try and write it on every atom in the universe, you would run out of atoms long before you finished. This is the duration of the universe's long, dark Middle Age. Compared to this, the Age of Light was a mere spark, a fleeting microsecond of activity. We are the inhabitants of that microsecond, the witnesses to the universe's brief, energetic youth. We are lucky to live while there is still something to see, while there are still stars to light the way. The transition to the final era, the Dark Era, is the end of the narrative of objects. Once the black holes are gone, there is nothing left to happen. No more energy can be extracted, no more complexity can be built, and no more change can occur. The universe reaches its state of maximum entropy, a state of perfect frozen equilibrium. The reign of the dark remnants was the final bridge between a universe of things and a universe of nothing. As the last black hole evaporates in a flash of light, it marks the end of the last interesting thing that will ever occur. The story of the universe is almost finished. As the world around you remains in a quiet stillness, let the peace of this immense scale wash over you. The universe has plenty of time. It is not in a hurry to reach its end. The slow, patient evaporation of the black holes is a reminder that the cosmos operates on its own terms, according to its own rhythms. We are the children of the morning, but the black holes are the elders of the night. They carry the weight of everything that ever was, holding it tight until the laws of physics finally demand its release. There is a profound sense of closure in this process, a feeling that the universe is meticulously cleaning up after itself, leaving the stage as empty as it was in the beginning. The journey through the far future is nearly complete. We have seen the stars fade, the atoms decay, and the black holes evaporate. We have moved from the world of light to the world of shadows, and finally to the world of pure empty space. In the next chapter, the evaporation of the Titans, we shall look more closely at the final moments of these dark rulers and the strange quantum world that they leave behind. For now, rest in the knowledge that you are part of a narrative that spans a Google years. You are a temporary arrangement of stardust in a universe that will eventually be a realm of pure, dark peace. The silence of the night is the same silence that will eventually conquer the cosmos. But while we have the light, let us use it. While we have the warmth, let us feel it. The black holes are still billions of years away from their final reign. Our sun is still shining, our world is still vibrant, and our story is still being written. The deep future is a landscape of the mind, a way to understand the ultimate reach of the laws of physics. But the present is where we live. Sleep well, knowing that the universe is vast, ancient, and patient beyond measure. The dark remnants are waiting, but the morning is still ours. In this absolute, enduring darkness, the narrative of our universe has arrived at its penultimate and perhaps most surreal phase. We have left behind the era of atoms and the long, slow cooling of the diamond stars. And now, as the world around you remains in a profound stillness, we shall witness the final, agonizing breaths of the true masters of the abyss. Tonight, we shall trace the slow quantum evaporation of the last Titans, the supermassive black holes, following their journey from cold, unmoving monuments of gravity to the violent, high-energy flashes that will mark the ultimate end of all structured things. This is a story that requires a patience beyond the capacity of any living mind, for we are now moving through the final Google years of existence, where time itself stretches out like a fine silk thread, almost to the point of breaking. The Titans we observe now are the survivors of a long-vanished age, ancient entities that once anchored the hearts of the great spiral galaxies. They are immense, some containing the mass of 50 billion suns within a sphere no larger than our own solar system. For aeons, they have sat in the dark, silent and invisible, having long since consumed every star and every planet that ever fell into their gravitational grasp. But even these kings of the night are subject to the subtle, unrelenting laws of the quantum world. At the very boundary of their existence, the event horizon, the universe is performing a quiet and constant act of subtraction. It is here that we find the secret to their demise, a process that is as delicate as the flutter of a moth's wing, yet powerful enough to eventually dissolve the heaviest objects in the cosmos. To understand how a titan evaporates, we must peer into the vacuum of space, which we once thought was empty. In truth, the vacuum is a roiling, energetic sea, where pairs of virtual particles are constantly appearing and disappearing, born of the uncertainty that defines the subatomic realm. Usually, these pairs, a particle and its antimatter counterpart, find one another instantly and vanish in a tiny burst of energy. But at the edge of a black hole, the geography of space is so warped that the rules of the game are changed. Occasionally, one member of a pair is pulled across the event horizon and trapped forever, while its partner is left stranded on the outside, free to escape into the void. To an observer, it appears as if the black hole has emitted a particle of radiation, and because energy must be conserved, the black hole must lose a tiny, infinitesimal portion of its mass to pay the price for that particle's freedom. This is Hawking radiation, the final, faint whisper of a dying universe. For a supermassive black hole, this whisper is so quiet that it is virtually undetectable. A titan the size of a galaxy is colder than the background of space itself, emitting energy at a rate so slow that it takes trillions of years to lose even a fraction of its weight. In this era, the universe is so vast and so empty that a black hole might not encounter another particle for 1,000,000 years. It sits in a state of absolute isolation, slowly exhaling its mass, atom by atom, into the eternal night. Time in this period has lost its human meaning. We are no longer counting in years or centuries, but in powers of 10 that defy the imagination. It is a slow, rhythmic decay, a cosmic clock ticking toward a midnight that is still a Google years away. As the millions of years turn into billions, and the billions into trillions of trillions, the Titan begins to shrink. The process is self-reinforcing, governed by a logic that seems almost cruel. As a black hole loses mass, it actually grows hotter. The smaller it becomes, the more intensely it radiates. For the first many billions of years, the change is imperceptible. The event horizon, that dark shroud that hides the singularity, remains a vast, unmoving wall. But the mathematics are patient. Over the course of 10 to the power of 80 years, the black hole that once swallowed entire clusters of stars is reduced to the mass of a single star. It is now a much more active participant in the darkness, glowing with a faint thermal light that was once buried deep within its gravitational well. Imagine the perspective of this shrinking giant. For aeons, it was the absolute master of its domain, a place where time stood still and gravity was infinite. Now, It is being eroded by the very vacuum it once dominated. The event horizon is contracting, its surface area decreasing with every particle that escapes. As the mass drops, the temperature begins to rise more rapidly. What began as a cold, dark void is now a glowing point of radiation. The Titan is no longer a silent king. It is becoming a beacon, a final source of light in a universe that has been dark for longer than we can possibly conceive. It is the long, slow transition from the macroscopic to the microscopic, a journey from the heavy and the slow to the light and the fast. The scale of time we are contemplating is so immense that we must find new metaphors to describe it. If you were to take a single grain of sand from the Earth every 1 billion years, you would have moved the entire planet many times over before the last supermassive black hole has even reached its middle age. In this profound stretch of eternity, the very expansion of space has reached such an extreme that even the light emitted by these evaporating titans can never reach any other point in the cosmos. Every black hole is dying in its own private universe, a solitary ending that has no audience. The silence of the void is absolute, broken only by the rare rhythmic tap of a single escaping photon, traveling forever through a space that is expanding faster than the light can move. As the final Google years approach their end, the evaporation process enters its final, violent stage. A black hole that has survived for 10 to the power of 100 years has now shrunk to the mass of a large asteroid. Its temperature is now measured in millions of degrees. It is no longer a dark remnant. It is a brilliant white-hot spark, screaming its mass away into the vacuum. In its final seconds, the Titan undergoes a catastrophic transformation. The remaining mass, billions of tons of matter, is converted into energy in a fraction of a second. This is the final explosion of the black hole, a burst of gamma rays and high-energy particles that illuminates the empty universe for one last, blinding microsecond. This is the only event that has occurred in the universe for trillions of years, a final firework marking the end of the black hole era. Consider the intellectual honesty of this moment. We are watching the laws of physics conclude their long work. Gravity, which built the stars and the galaxies, has been defeated by the quantum fluctuations of the vacuum. The mass that was once part of your world, the iron in your blood and the carbon in your bones, has been processed through the event horizon, held in the dark for an eternity, and finally released as pure, stretched light. There is no matter left. There are no remnants. There is only a thin, cold sea of radiation, moving through a space that is so vast and so empty that the concept of a location has lost all meaning. The evaporation of the Titans is the final purification of the cosmos, the last act of the long, slow return to the void. Linger for a moment on the silence that follows the final flash. When the last supermassive black hole has vanished, the universe has truly and finally finished its business. There are no more sources of energy, no more wells of gravity, and no more structures of any kind. The expansion continues, stretching the final bursts of radiation to infinite wavelengths, until they are no longer detectable even in theory. The universe has reached its state of maximum entropy, a state of perfect frozen equilibrium. This is the heat death, not a death of fire, but a death of absolute cold and stillness. The Titans have done their duty. They have carried the matter of the universe to its final destination, and then vanished, leaving behind a canvas that is once again as blank as it was before the first light was ever struck. Time threes. As you lie here, reflecting on this ultimate end, find peace in the grace of the process. The universe did not end in a hurry. It did not collapse in a panic. It took a Google years to carefully and meticulously dissolve every structure it had ever created. The evaporation of the Titans is a testament to the patience of the laws of nature, a slow and majestic closing of the book. We are the inhabitants of the bright, energetic morning, but the story we are part of is one that values the long, silent afternoon and the final, dark evening just as much. The end of the black holes is the final proof that everything in the universe is connected, from the largest galaxy to the smallest quantum jitter, and that everything eventually finds its way back to the silence of the beginning. The scale of a human life, measured in decades, is a rare and precious spark in this immense narrative. We are the ones who get to experience the universe when it is still full of action, when the light still shines, and when the Titans are still growing. We are the witnesses to the high drama of creation. The deep future, with its slow evaporation and its eternal night, is the necessary conclusion to our vibrant present. As the world around you remains in a quiet stillness, let the realization of this immense timeline anchor your soul. You are a part of a 13 billion-year history that is heading toward a Google year peace. The dark remnants are not something to fear. They are the final guardians of the cosmic story, the ones who ensure that the silence is absolute and the rest is eternal. The journey through the far future is almost at its end. We have seen the lights fade, the atoms decay, and the black holes evaporate. We have moved from the world of light to the world of shadows, and finally to the world of pure, empty space. In the final chapter, we shall step into the absolute silence of the eternal void, to explore what remains when the last particle has vanished and the last photon has been stretched into infinity. It is a place of profound peace, the ultimate destination of every journey we have ever taken. But for now, rest in the knowledge that you are part of a narrative that is larger than time itself, a child of the stars who is dreaming in the shadow of the Titans. The silence of the night is now the silence of the far future. The same gravity that holds you to your bed is the gravity that will one day evaporate into the dark. The universe is ancient, patient, and beautiful in its decline. As you drift closer to sleep, imagine the final flash of the last Titan, a brief and brilliant goodbye to a universe that has finally found its rest. You are safe in the arms of these immense laws, a participant in a story that spans a Google years. The stars are gone, the black holes are finished, and the silence is finally complete. Sleep well, knowing that you have seen the end of all things, and that the end is a state of perfect dark peace. The final firework has vanished. The last burst of gamma radiation from the final evaporating Titan has swept across the dark, traveling for an eternity through a space that is now so vast it defies the very concept of measurement. With the departure of that last flash, the universe has entered its ultimate and permanent state. This is the Dark Era, the final epoch of the cosmic narrative, where the story of things and events comes to an absolute, unmoving end. We are standing now in the silence of the eternal void, a realm of such profound emptiness and stillness that even the passage of time has lost its meaning. The universe has finally achieved what it has been seeking for a googol years, a state of perfect frozen equilibrium. In this absolute desolation, there is no matter left to cast a shadow, and no light left to illuminate the dark. The protons have decayed, the stars have crystallized and evaporated, and the black holes have breathed their last. All that remains is a thin, ghostly sea of individual particles, photons, neutrinos, and the occasional electron or positron, drifting through a vacuum that is expanding at an ever-accelerating rate. These particles are now separated by distances so immense that they will never, in the remaining life of the universe, encounter another of their kind. Every single particle is now the sole inhabitant of its own private universe, a lonely traveler in a dark that is millions of trillions of light-years wide. As you lie here, try to imagine the scale of this emptiness. In our current age, the space between the stars is a crowded neighborhood compared to the void of the deep future. The expansion of space, driven by the relentless push of dark energy, has stretched the fabric of reality to its breaking point. The photons that were once the brilliant light of the stars have been redshifted to such extreme wavelengths that their energy is effectively zero. They are no longer light, but a faint, rhythmic vibration of space itself, moving through a medium that offers no resistance and no destination. The universe has become a place of absolute transparency, a glass-like expanse where nothing can ever happen again. The concept of time in the eternal void is perhaps the most difficult thing for the human mind to grasp. We measure time by change, by the movement of a clock, the rotation of a planet, or the pulse of a heart. But in a universe where nothing moves and nothing changes, time loses its arrow. There is no before and no after, for every moment is identical to the one that preceded it and the one that will follow. The universe has reached its maximum state of entropy, a condition known as heat death. It is the point of total exhaustion, where all the energy that was once concentrated in the Big Bang has been spread so thin that it can no longer perform work. The cosmic clock has finally run down, and the hands have stopped moving forever. Linger for a moment on the silence of this finality. It is not the silence of a room or the silence of a forest, but a silence that is built into the very laws of physics. There is no air to carry a sound, no matter to vibrate, and no mind to perceive the stillness. The universe is a vast, empty stage where the play has long since finished, the actors have left, and the lights have been turned off. Yet, the stage remains. The vacuum of space, though empty of matter, is still governed by the laws of quantum mechanics. Even in the absolute dark, the vacuum is alive with the subtle jitters of uncertainty, tiny fluctuations that are the last remaining signs of activity in a dead cosmos. Pitch 1%. Intellectual honesty requires us to ask if this is truly the end of the story. Some theories suggest that over periods of time so long they cannot be written in numbers, the random jitters of the vacuum might spontaneously trigger a new Big Bang. Through a process of quantum tunneling, a new universe could blossom out of the ruins of the old, beginning the cycle of stars and life all over again. Others speak of a Poincare recurrence, where after an incomprehensible duration, the particles of the void eventually find themselves in the exact same configuration they occupied at the moment of your birth. In an infinite timeline, even the impossible becomes a certainty. But these are the whispers of a distant hope, theoretical possibilities that exist far beyond the horizon of the observable. For all practical purposes, the silence of the eternal void is the final destination. The story of the universe is a narrative of cooling, thinning, and fading. We are the inhabitants of the first brilliant chapter, a time of heat and light that will eventually be forgotten by the very space that created it. There is a profound sense of peace in this realization. The universe is not a chaotic accident, but a meticulously governed process that leads to a state of absolute rest. The end is not a tragedy, but a fulfillment, the final, quiet breath of a cosmos that has finished its work. The silence is the reward for 13 billion years of fire and fury. As you contemplate this ultimate stillness, find comfort in the stability of the void. It is a place where nothing can ever go wrong, because nothing can ever happen. The conflicts, the fears, and the anxieties of our present age are all dissolved in the profound equilibrium of the deep future. The universe has found its peace, and we, as its temporary residents, share in that legacy. We are the way the universe experienced its youth, and our memories are part of the information that was once carried by the stars. Even when the stars are gone, the fact that we were here remains a permanent part of the cosmic record, a brief but beautiful melody in the long, silent symphony of time. The scale of the eternal void is the ultimate measure of our own lives. We have a few decades to witness a story that lasts for a Google years, and then drifts into a silence that lasts forever. This makes our current moment, the here and the now, the most precious thing in the cosmos. We are the ones who get to hear the music while it is still playing. We are the ones who get to feel the warmth before the cold becomes absolute. The journey through the far future has not been a journey away from life, but a journey that highlights the incredible, improbable value of the life we have. We are the sparks in the dark, and for this brief microsecond of history, we are everything. The silence of the night around you is now a reflection of the silence of the eternal void. But for you, the silence is a place of rest and renewal. You can still feel the warmth of your breath and the steady rhythm of your heart. These are the sounds of a universe that is still very much alive, still full of potential, and still telling its story. The far future is a landscape of the mind, a place to visit in our dreams to understand the ultimate scope of reality. But the present is our home. The stars are still there, the black holes are still growing, and the morning is waiting to begin. As you drift into the final depths of sleep, let the vastness of the eternal void be a cushion for your thoughts. You are a part of a 13 billion year narrative that is so well designed that even its end is a masterpiece of peace. You have seen the fading of the lights and the evaporation of the Titans, and you have found that the end is nothing to fear. It is a state of absolute dark grace. You are a child of the stars, a witness to the fire, and a keeper of the silence. The journey is finished, the questions have been answered, and the rest is finally here. The universe is vast and you are small, yet you have traveled to the very end of time and returned. You carry the wisdom of the Google years within you, a quiet confidence that comes from knowing the ultimate fate of all things. Sleep now, in the perfect equilibrium of the night. The eternal void is waiting in the far, far distance, but tonight you are here. You are warm and you are loved. The story of the last star has been told. The final black hole has vanished, and the silence is complete. Good night, traveler of the deep space. The cosmos is at rest, and so are you.